Hello, Honors Algebra 2 Trig students. Today's notes are our second day of modeling exponential functions. And we had the equation yesterday of y equals ab to the power of x, or the power of t, whatever the input variable is. And this is the base exponential equation for exponential growth and exponential decay. Uh, we have two different versions of it coming here. There's this formula on your left. That is the compounding interest formula. And what's happening is this A is your initial amount. And unlike other formulas that we had with just the 1 plus the r to the power of t, we have this n. And the n is the number of times to compound per time unit. So what we have would be, for example, if we wanted to spread out a certain amount of interest. For example, say you had 12% interest per year. If you compound monthly, that's 1% per month. Now, 12% compounded yearly and 1% per month is actually different, because what happens is if you had, say, $1,000, and here we go, we're going to get out a calculator, and you were doing 12% per year, you could just multiply by 1.12 in every year. Well, okay, let's get that out of the way. If you have $1,000 times 1.12, that's it in the first year, would get you to 1,120, added 12% in. If you did it again, the second year, you'd be 1254.4, which would be getting interest based on that interest. Now, if you did the 1% every month, this would be, if you multiplied by times 1.01, it would add 1% in. Now, if you did that 12 times, oh, sorry, that's totally not what I wanted to do. Here's the second month, third month, fourth month, fifth month, sixth month, seventh month, eighth month, ninth month, 10th month, 11th month, 12th month. And this is $6.82, sorry, $6.83 different than our version that was just 12% in a year. Because as you can see, the interest that you have is making interest throughout the year based on how often it's compounding. And the more often you compound, the bigger the difference it will make. Now, there's something called compounding continuously. That would be compounding even more often than monthly. And even more often than monthly, it might be daily. So you might be able to compound something on a daily level that would be 365 times per year, which would give you a lot less than 12% each time, to give you a 365th of a 12th. But we could get you compounding literally every second of every minute of every day. And that is where this formula comes into play. This is the compound continuously formula. That's y equals PE to the power of RT. Now, if you have $5,000 into account that yields 5% year, how much will it be worth in 8 years? Well, it doesn't say anything about compounding any more often than once per year. So you have y equals 5,000 times 1.05 to the power of t, and in this case, the time is 8. So we can take out our calculator, 5,000 times 1.05 to the power of 8. So that would give us 7,387.28. Now, we're going to do something a little bit differently here. We put it $3,000 into an account that yields 4% compounded monthly. Now, we're going to set up the equation different here. We started with $3,000. It yields 4% interest. However, I'm not going to write 1.04 because we're going to be getting a 12th of that 4% every month. Now, in a year, this interest amount that we have in this spot, this interest amount is 1/3 of a percent. We won't be getting that 1/3 percent every year. We're going to be getting it way more often. We're going to be getting it 12 times a year. So if we were to write this here just being t, it would be saying we get that 1/3 of a percent added in once a year. Because when t is 1, it would multiply this in once. However, we want it 12 times as often, which matches our formula. Use this formula, and that's the formula we have going so far. This smartboard is not my typical smartboard, and it is not working the way I would expect it to. There we go. Now, wants to know how long until the account is worth. That's the wrong problem. Let's get back to where we're supposed to be. Here we go. 4% compounded monthly. We want to know how much it will be worth in 5 years. So we can go ahead and put this here being 5. So you have y equals 3,000 times 1 plus 0.04 divided by 12 to the 60th power. So that's what we'll plug into our calculator. We have 3,000 times 1 plus 0.04 divided by 12 to the power of 60. So we have 3,662 and 99 cents. So 3,662 and 99 cents. Now the next one we have compounding continuously. Well, we're going to use that formula P equals E to the power, our amount is equal to P E to the power of RT. So our initial amount was 10,000. It's compounding 3% continuously. This is the equation that relates the time that has gone by to the amount that is in the account. This is written as 1,000. It should have been 10,000, so I'll put that extra zero in there. Then we want to know how long until it's worth $15,000. Well, that's the amount that it's valued at. So we have 15,000. We can replace as y. 10,000 e to the 0.03 t. We're trying to get to where this exponent is, so we can divide over our 10,000 to get 15,000 over 10,000 equals e to the 0.03 t. These thousands can reduce. The 15 over 10 is 3 over 2. And so we can change this now into log form. Log base e of 3/2 equals 0.03 t. So I would see that our time is the natural log of 3/2 divided by 0.03. So if we go into our calculator, the natural log of 3/2 being 1.5, and then divide that result by 0.03, will tell us how many years it would take. It takes 13.516 years for the investment to hit $15,000. All right, so we know Mr. Mead, he's secretive about an investment strategy. He's not going to tell us how much money he recently invested into the math department investment account that has an 8% interest compounded quarterly. We want to know how long it will take for Mr. Mead to quadruple his money. Now, it's compounded quarterly, so we know we can use this formula. Y equals A, 1 plus the rate divided by the number of times compounding, 4 times per year is quarterly, to the power of 4t. And we also know that this rate is 8%. So we have 0.08. So we know that Mr. Mead, every one of those payments is getting 2% of his money. Now, I don't know how much he invested, but I want to know how long it takes for him to quadruple it. So what's going to happen is that we can rewrite this Y value as 4A. It's quadruple or 4 times the original amount. So we want to know how long it takes until I'm dividing by A on both sides. This part becomes 4. Well, we can solve this with a log. Log base 1.02 of 4 is equal to 4t. So our t is log base 1.02 of 4 divided by 4. Which now if we go use our calculator, math log base 1.02 of 4. If we divide this by 4, we get 17.501 years it's going to take him to quadruple his money. So this is 17.501 years.